Question 3, Part A. In the diagram, A, B and C are the points -2, -4, 12, 6 and 6, 8 respectively. The point N, 2, 2 is the midpoint of AC. The point M is the midpoint of AB. Part 1. Find the coordinates of M. Since the point M is halfway between point A and point B, to find the x-coordinate of point M, we average the x-coordinates of point A and point B, and to find the y-coordinate of point M, we average the y-coordinates of point A and point B in a similar way. So here's the working out to find the coordinates of point M. So the x-coordinate of M is -2 plus 12 in brackets divided by 2, which gives us 5, and the y-coordinate of M is -4 plus 6 in brackets divided by 2, which gives us 1. Therefore, the coordinates of point M are 5, 1. Part 2. Find the gradient of BC. To find the gradient of an interval, we divide the change in y, or the vertical change, by the change in x, or the horizontal change, working from left to right. In other words, gradient M is equal to rise over run, or rise divided by run. Let's consider interval BC. Now point C is to the left of point B, and we know this by considering the x-coordinates. Now working from left to right, we can see that the y-coordinate of point C is 8, and the y-coordinate of point B is 6. So the change in y is found by subtracting 8 from 6, or 6 minus 8. Now to find the change in x, we find the difference between the two x-coordinates. So 12 minus 6 is equal to 6. So showing the working out, the gradient M is equal to change in y divided by change in x, or rise divided by run. Now the change in y is 6 minus 8 in brackets. The change in x is 12 minus 6 in brackets. And dividing those two quantities, we get -2 divided by 6, which gives us -1/3 as a fraction. Therefore, the gradient of BC is -1/3. Part 3. Prove that triangle ABC is similar to triangle AMN. The overall strategy is to show that MN is parallel to BC, given that this angle here is common to both triangles AMN and ABC. And if we can show that MN is parallel to BC, then we have a pair of corresponding angles. Then we can show that the two triangles are similar using the equiangular test. So here is the proof. Angle BAC is common to triangle ABC and triangle AMN. Now N is the midpoint of AC, which is given in the question. M is the midpoint of AB, which was proven in part 1. Hence, MN is parallel to BC. So angle AMN is equal to angle ABC, and their corresponding angles, given that MN is parallel to BC. Therefore, triangle ABC is similar to triangle AMN, and the reason is equiangular. Part 4. Find the equation of MN. Since MN is parallel to BC, which we've proven earlier, the gradient of MN is equal to the gradient of BC, which equals -1/3. Now the point N, 2, 2, is on interval MN. So using the point gradient formula, y minus y1 is equal to m times x minus x1 in brackets, where y1 is equal to 2, x1 is equal to 2, and m is equal to -1/3. So substituting those values for those variables, we have y minus 2 is equal to -1/3 times x minus 2 in brackets. Multiplying the left-hand side by the denominator 3 to eliminate this denominator here, we get 3y minus 6 is equal to negative outside of x minus 2 in brackets. Expanding the brackets here, on the right-hand side, we get 3y minus 6 is equal to -x plus 2. And then moving all the terms on the right-hand side over to the left-hand side, so we get the equation in general form, we get x plus 3y minus 8 equals 0. Therefore, the equation of mn is x plus 3y minus 8 equals 0. Part 5. Find the exact length of BC. We can form a right-angled triangle around interval BC, where BC is the hypotenuse of this triangle, and the two short sides are parallel to the coordinate axes. Now, the length of the horizontal short side is the difference in the x-coordinates of points B and C, so it's 6 units, and the length of the vertical short side is the difference in the y-coordinates of points B and C, and that's 2. Showing the working out, using Pythagoras' theorem, we have BC squared is equal to 12 minus 6 in brackets squared plus 6 minus 8 in brackets squared, or we could write it as 8 minus 6 in brackets squared. It doesn't matter whether it's negative or positive inside the brackets. Since we're going to square it, the negative will turn into a positive anyway. So evaluating the right-hand side, we get BC squared is equal to 40. Now we need to take the square root of that to find the length of the hypotenuse. So BC is equal to the square root of 40, or 2 root 10 units in simple surd form. Part 6. Given that the area of triangle ABC is 44 square units, find the perpendicular distance from A to BC. The question is asking for the perpendicular distance from point A to the line through BC. Now, this perpendicular distance, which I've marked with a H, also represents the height of triangle ABC. Now, from part 5, we have the length of the base of this triangle, that's interval BC, which is 2 root 10 units, and we're given that the area of this triangle is 44 square units. That gives us a clue as to what to do next. Using the area formula, area equals half times base times perpendicular height, we can then solve for H, hence finding the perpendicular distance from point A to the line through BC. So the area is equal to half times base times perpendicular height. So 44 is equal to half times 2 root 10 times H. Now half times 2 equals 1. So the equation simplifies to 44 equals root 10 times H. Dividing both sides of the equation by root 10 to make H the subject, we get H is equal to 44 over root 10. Therefore, the perpendicular distance from A to BC is 44 over root 10 units.